Platform engineering and site reliability teams need to validate how their services respond to and recover from failures before incidents occur in production. AWS Resilience Hub now provides recommended resilience tests that address this challenge. You can validate service recovery from failure scenarios using pre-configured tests tailored to your architecture, configuration, and resilience policy. The service uses AWS Fault Injection Service to inject control faults into your resources. You can test common failure patterns including availability zone impairment, regional impairment, and dependency failures. Each test automatically targets the appropriate resources, injects faults, and evaluates whether your service recovers within your defined recovery time objectives. You receive pass or fail outcomes based on alarm evaluation and recovery objectives, along with detailed test reports to help you identify gaps in your resilience posture. Sharing game streams previously required end users to have AWS credentials, install software, or integrate client code. Amazon GameLift Streams now provides stream URLs that enable temporary, unauthenticated access to playable stream sessions directly in web browsers. You can generate temporary URLs for a stream group and application, then configure how long each URL remains valid and how many sessions it can initiate. Recipients open the link in their browser without requiring AWS accounts, credentials, or software installations. Each recipient starts an independent stream session, and GameLift Streams routes them to a nearby streaming location from your selected regions. You can manage URLs through the GameLift Streams console or use the new Create Stream URL, Get Stream URL, List Stream URLs, and Revoke Stream URL APIs. No client integration or backend service implementation is required. You pay only for the stream capacity consumed by sessions started from stream URLs, with no additional charges for the URL feature itself. Previously, you had to split large assets across multiple layers or offload them to external storage systems when building container images, adding complexity to your workflows. Amazon ECR now supports image layers up to 200 GB for images pushed via Docker push, up from the previous limit. You can store up to 200 GB in a single image layer, enabling you to embed large language models directly in your container images. You can bundle genomics datasets without splitting them across layers, simplifying data packaging. You can package large binary dependencies without requiring external storage systems. This eliminates the need for workarounds when dealing with large assets. Images pushed using the AWS SDK or CLI remain limited to 50 GB. This feature is available in all AWS regions where Amazon ECR operates except Middle East, Bahrain, and UAE. When you need models to learn domain-specific knowledge beyond surface-level adjustments, parameter-efficient methods like low-RA that update only a subset of weights may be insufficient. You can now use full fine-tuning on SageMaker AI serverless model customization to update all parameters in over 25 open-source models from families including Llama, Gemma, and Qwen. This enables models to thoroughly learn your domain patterns, terminology, specialized reasoning, and complex output formats from proprietary datasets. SageMaker manages all infrastructure provisioning and training orchestration, so you can run full fine-tuning jobs without managing infrastructure and pay only for what you use. The capability is available in US East, US West, Asia Pacific Tokyo, and Europe Ireland regions through SageMaker Studio or the Python SDK. Engineering teams struggle to manage technical debt and security issues across multiple source code repositories at scale. You can now use AWS Transform continuous modernization to address this challenge. You connect your GitHub organizations, GitLab groups, or Bitbucket workspaces to analyze code on demand or on recurring schedules. You schedule analyses to identify technical debt, security vulnerabilities, agentic readiness, and modernization readiness across your repositories. You generate automated pull requests containing validated code changes that AWS Transform creates as branches in your repositories for review. You analyze repositories locally from your IDE or terminal, or remotely using Amazon EC2 or AWS Batch, while your source code remains under your control. Analysis and remediation run in your AWS account using your credentials, giving you control over the process and data security. Managing compliance and configuration tracking across expanding AWS environments becomes difficult when resource types are not supported by monitoring tools. You need visibility into services like Amazon Bedrock, OpenSearch Serverless, and SageMaker to maintain consistent governance and audit capabilities. AWS Config now supports 15 additional resource types including Bedrock Automated Reasoning Policies and Blueprints, OpenSearch Serverless Access and Lifecycle Policies, and SageMaker Inference Components and Projects. You can track these resources automatically if you have enabled recording for all resource types. You can apply config rules to evaluate compliance of these new resources against your organizational standards. You can aggregate compliance data across accounts and regions for these resource types through config aggregators. The new resource types are available in all AWS regions where the underlying services operate, enabling you to maintain configuration history, assess changes, and remediate non-compliant resources across your entire infrastructure.